Hello everyone, welcome back. This is the latest project, and this was very kindly again sent from Mike, Racing Demon in Northern Ireland. He sent me the couple of amplifiers last year and a tuner, which is really nice of him to support me by sending me stuff to play with. And this thing in front of you is a Roberts R66 portable valve radio, although it does have a mains transformer in it as well, so you can run it on the mains also. And this turned up a couple of days ago, but it's been so cold I haven't fancied being in the workshop. I've got the heater on now. It's still cold today, and the temperature is 8.7 degrees centigrade in my workshop, but it's gradually going up with the heating on. So I shall stay out as long as I can videoing until I get hypothermia. Anyway, this is the R66 Roberts, as I said. Made in about 1955 according to the service documents. So that would have been just on the edge of when transistor radios would have come in the probably in the late 50s. Making this rather redundant, but I'm quite surprised how small it is considering it's got valves in it. Anyway, it's in fairly good condition. The grill is plastic and no damage. The case is okay-ish. It's got a little bit of damage here and there. By no means is this radio perfect, but considering its age, I think it's survived fairly well. Sadly, it has a knob missing. Should have these hexagonal, is it hexagonal? 1, 2, 3, 4, 5, 6, 7, 8 octagonal, whatever knobs, plastic knobs, and this is the replacement that's been put on, which is a bit sad. I've had a look around on the internet, can't easily find one of those. I guess you could 3D print one. I don't know if you can 3D print in white. I imagine you can. Well, I haven't got a 3D printer. I'm not that rich. The other thing is the strap is fairly tatty. Obviously they get a fair bit of hammering when you're carrying it around. If this thing works, and I'm sure it will do eventually, I'm looking at getting some red leather. I had a look around on eBay and found belt material in, I think it was nearly 3mm thick, which is roughly what that would be. Belt material for making belts out of. Perfect width, I think it was just slightly wider than that. My only problem with the colour is I think it might be quite a bright red compared to the colour of the case. So I may experiment with brown boot polish to see if I can tone it down a bit. I think I've got some brown boot polish. I hardly ever polish my shoes, so it's been around for about 20 years as it is. So let's have a look around the back of it. The back of it also looks, there's some bit of nastiness here and there, but as I said, considering its age, what is it? 65 years old, 1955. It's 6 years older than me. Wow, that's when it was designed, 1955. So let's open it up. And that's what it looks like. Let me prop it up a bit. Don't think that's going to work, but it might do. So all looks fairly good inside, nice, not too much dirt or dust or anything else nasty in there. Uses a ferrite rod, which is quite nice. I don't know whether that's snapped at some point. It's got tape, or was it just tape to hold the coil? No, I think the ferrite rod is in fine condition by the looks of it. Some strange person, well, first of all, that's your low tension connection for a 1.5 volt battery for the heaters of the valves, because they run on very low voltage 1.5 volt heaters. But HT runs on 90 volts, so you'd have a 90 volt battery in there as well. Some strange person has put a PP3 connector on here. I wonder if they thought it was going to work on a PP3 9 volt battery. Well, I'll have to dispose of that, and I think I'll probably just get rid of all this crap and just put a piece of heat shrink over the connections to the battery, because it's not going to get used on battery, it's going to be on mains only, hence the fact that you've got a mains lead which comes out of there. And like other people have said on videos, it's got the old traditional black and red for live and neutral. Now we've left Europe, we can forget all that silly brown, blue and green, maybe go back to black and red. Well, I don't think that'll happen, because it's been around so long now, everybody's familiar with blue and brown and green. Anyway, it's got what has it got? It's got four valves in it. Yeah, 4 valves. And let me try and think a rough guess what they're doing. I'm guessing that's the oscillator mixer valve, and that'll be the IF valve, 2-stage IF transformers. And then we've got a preamplifier and detector, maybe that one, not sure. Well, that might be the output, as it's near the output transformer. So anyway, you've got a preamplifier and detector in one valve. That'll feed the output stage, obviously. And what else can I say? Various voltage selections, don't know if you can see that. Can have 200, 210, 220, 230, or 240, 250, and I'll probably keep it on the 240, 250 when I'm testing it, because mains these days tends to be a bit higher than it used to be. Well, it's probably around 240 average here. So what should I do now? I should think we could look at the service sheet I've got for it. Okay, here's the service data, which Mike kindly sent me as well. And I'm not going to read through all this stuff, because it just describes how the circuit works, and we all know how the circuit works, don't we? But the most useful thing it really is the circuit diagram, and as is predicted, we've got your long and medium wave coils there, which are switched, obviously, tuning capacitor, and that's the oscillator and mixer valve, and that'll be the oscillator coils for long and medium wave, presumably, which are switched. And up there we have the first IF transformer, I should think, yeah, going into a second IF amplifier valve, or first IF amplifier valve, then through that, and what does it do? Oh, it must be, yeah, must be detecting in there as well. There must be a second IF amp and detector, because on the output of that coil we have audio, because that's the volume down there, volume control down there. And just trying to get my head around this, because I don't do valves that much, so it's all good experience for me. And yet we've got a signal coming off here to this valve. Not entirely sure how this all works. Some sort of AGC maybe. Oh, it's cold out here. 10 degrees now. And that's the problem with this outside shed. It takes ages to warm up when it's as cold as it is outside. So after that we've got a signal coming out and going into this power output valve, which will drive the impedance matching transformer, which is simple enough. Yeah, that's a silly little symbol for a speaker. I was trying to find the speaker, but there wasn't one. It's just that silly little symbol there. And apart from that, we've got some power supply stuff going on here. We've got mains coming in to a mains transformer, obviously, 2 secondaries, and the top secondary is for your HT, which I would guess, and I haven't looked at it, is around 90 odd volts. Well, it would be, wouldn't it, if you've got a 90 volt battery. And they're rectifying it with a selenium rectifier, which are always fun when they go wrong because they smell like boiled cabbage. But I'm going to leave them in if it works. I'm not going to try and change it to silicon rectifier. So then you've got your rectifier for HT, a bit of smoothing, a dropper resistor, which I guess will do a bit of filtering, maybe. I don't see any decoupling capacitors along the HT, so it's just, oh yeah, yes there is one, C26. Okay, so that resistor's giving you a bit of filtering, and C26, does that go to earth? Doesn't seem to go to earth, it goes to, or whatever. I'm not going to worry about any of that. And then we've got a load of switching here, so it's switched between battery operation and mains, and that's the second transformer winding, which is for the low tension 1.5 volts center tapped transformer to earth, and full wave rectification using again a selenium rectifier, and then loads of filtering. We've got no less than 3 capacitors and 2 resistors in the filtering of the heater supply. I guess they want to keep out any AC getting into the heater, which makes sense. It wants to be pure as DC as possible. And we've got all the information on the switches, and on the top of the switch, from when you switch it from off to medium and long, you've actually got medium and long on battery and medium and long wave on mains. So that's interesting, I think. And but I do wonder now, as things are going on, how much longer a radio like this is going to be any use in the UK, because I've got a terrible guitar. I always have had it since I was 15, so I haven't caught the virus yet, so it's not to do with that. So yeah, I do wonder though how long we're going to have medium and long wave, because a lot of the European stations have shut down. There's hardly anything on long wave now apart from Radio 4 and RTE in Ireland. And on medium wave, a lot of the local stations are closing down their medium wave transmissions, just FM only or DAB. And medium wave now seems to have been taken over by the Spanish, so this radio will be fine if you speak Spanish. What else we got here? Got a layout of all the different whatever. That's one side of the circuit board, or one side of the chassis I should say. It probably hasn't got a circuit board, and it shows you, very comprehensive, shows you where everything is, all the adjustment points, which is good. And that's the side that you're seeing when you look in the case, and the adjustments for when you do the alignment, various capacitors, and that's probably the oscillator coil. So, and the final bit of this is a comprehensive list of all the components, which is good. And finally, circuit alignment details, which will be fairly straightforward. There's not much to do really, you just do the IF 470 kilohertz as it says there, and then you go in and you do the medium and long wave alignment, which is 5-10 minute job, maybe a bit longer, not too bad at all really, unless there's a problem with it. And God, I'm always shivering in here, it's so bloody cold. 11 degrees now, and I've had the heater on for the best part of an hour. So, and I have insulated this shed, but you know, it's just the way it is. So what I propose to do now is I'm not going to take this thing apart, I don't think, at the moment. I think what I'll probably do, and it's also got a cutout, I presume that's to stick the mains through there, mains cable. So I'm going to put all the odd wires back in it, and I think before even checking out whether the capacitors are bad or what in this thing, I think I'm going to stick it on a variac and just gradually wind it up, because we don't know when it was last used, do we? It might have been 10 years ago, it might have been 30 years ago, who knows. So we're going to try and reform those capacitors by gradually bringing it up on a variac. Okay, I've got it all wired up to my safe block up there, and then into the variac. So, and I've also got this current meter in series with the mains, because I want to measure fairly accurately what it's drawing. So I'm going to put the lid down on the safe block. Variac is set to 0, and I've got to be careful because I've got, that's live there. So just gradually turn it up. We want DC, we want AC, don't we? AC? Yeah, we want AC current, of course we do. So 10 volts, a little bit maybe. I don't think it'll start drawing much till you get fairly high up in input voltage. So that's 50 volts. Have I got it turned on? No, I bloody haven't, have I? I've got it turned on to battery, which is no good at all. So let's put it onto mains. And now we see a bit more current draw. That's 10 volts. And this silly meter doesn't start working till it gets to 70. So it's 2 milliamps at 20 volts. 30 volts, 4 milliamps. 40 volts, 50, 60, 70. Turn the volume up just in case it'll work, which it probably will, or probably won't, who knows. 80 volts, 10 milliamps, 90 volts, 100, 110. I don't know if I should let it rest there for a bit because of reforming capacitors. I'm not really into reforming capacitors, but anyway, I think I'm just going to gradually go up. 130 volts, 130 volts, and that equals 0.8 watts according to that crappy Chinese meter. 140 volts, 150 volts, 60, 170, 180. Not doing anything, is it? I thought I would have heard something by now if it was working. The worst case scenario is the valves are no good. Well, that's 210, it's not doing anything except draw 2.5 watts. I think it should be drawing more than that. That is a whatever, dead dingo's donga. 230, okay, it doesn't work, fine. I'm going to abandon this for today because it's too cold, and I'm going to have another go tomorrow. Get it out of its chassis. Get it out of its chassis and see what's going on. Measure a few voltages. So that'll be tomorrow's project.